Hello everyone, this is Haragopal. In this video, I am going to discuss the IMO 2020, that means a very recently International Mathematics Olympiad problem, and this is the geometry problem which was given as a first question on the question paper. And the reason behind choosing this problem to make the video is the entire problem as well as the solution is just based on below 10th standard concepts what we used to see regularly in our textbook. So that is the beauty of this question as well as the solution. So now before going to attempt the question and as well as the solution, first let me recall all those concepts first, then we'll move on to the question as well as the solution. The very first one is a very basic thing we used to learn from maybe 7th class onwards. That is, if you consider any triangle and if you extend the side, so the angle what you can see outside the triangle is called as exterior angle, and we know that exterior angle is equals to sum of these two angles. Usually we used to call as exterior angle property of triangle. So exterior angle is equals to sum of opposite interior angles. So this I'll consider as a concept one to solve this problem. And coming to the second one, suppose instead of triangle, let us consider this quadrilateral. As soon as you see, as all the vertices are on the circle, you can say this is a cyclic quadrilateral. And for the cyclic quadrilateral, if you extend any side, so you can see clearly one angle which is called as exterior angle. So in this particular case, exterior angle is equals to opposite interior angle, but in triangle, exterior angle is equals to sum of opposite interior angles. But here, exterior angle is equals to opposite interior angle. So this is the second concept of what we have to use in this solution. And coming to the third one, consider this circle. There is a circle and chord is there. For this chord, if you drop a perpendicular bisector or if you draw a perpendicular bisector, definitely that perpendicular bisector passes through the center. Usually we call as a perpendicular bisector of any chord passes through center. We used to see this one in circle chapter of 9th standard. So you may consider this theorem in another way also. From the center of any circle, if you drop to the perpendicular to any chord, definitely that perpendicular bisects the chord. So this is the third concept what we have to recall. And finally, consider this. This is an isosceles triangle. Consider these two are equal sides. So definitely the angle between equal sides we used to call as a vertical angle. So for this vertical angle, if you draw angular bisector, this angular bisector is going to be the perpendicular bisector of the base, which means this angular bisector will bisect the base at 90 degrees. So these are the four concepts of what we are going to use the solution of this problem. Apart from these four, I am not going to use any other concepts of geometry. So number one, exterior angle property of triangle. Number two, exterior angle property of cyclic quadrilateral. Number three, perpendicular bisector of chord passing through center of any circle. And finally, angular bisector of vertical angle of any isosceles triangle will be the perpendicular bisector of the base of that triangle. So these are the four concepts. So now let me remove this one, but keep all these 4 points in your mind. Now coming to the problem, first of all let me explain the question first. A, B, C, D is a convex quadrilateral, what was mentioned in the question. Now in that convex quadrilateral, P be any point such that if you join this P to the all the four vertices, you can see so many different angles, but here a proper relation was given between the triple of angles. So first let me explain the first one. So angle PAD, angle PBA and angle APD are in the ratio 1:2:3 what was given. So clearly that thing I am showing in the diagram, let me consider this as alpha, this is going to be 2 alpha, definitely this is going to be 3 alpha, which are in the ratio 1:2:3. Now apart from these three, one more triple of angles were given, that is angle PBC, angle PAB and angle BPC are also in the ratio of 1:2:3. So let me consider as beta, 2 beta and 3 beta. So these are the relation between the angles were given in the diagram, and the final question is if you take the angular bisectors of angle ADP and BCP, if you see the lower angles for these angular bisectors, if you draw, as well as the perpendicular bisector of this side AB. So two angular bisectors and one perpendicular bisector, all these three lines are concurrent at one point. That means all these three lines meet at same point, what we are supposed to prove in this question. So this is the exact question. Now let me discuss about the solution of this one. As I said earlier, only these four concepts I am going to use in this one. All these four concepts are just below 10th standard concepts only. So now let me remove this one. Take a simple diagram. So clearly you can see A, B, C, D is a quadrilateral. P is an interior point. Here wantedly I joined to A and B and D only. Now if you see clearly, here alpha is there, here 2 alpha is there, here 3 alpha is there. Now here as a first part, what I am doing on AD, taking a point E such that, please remember, such that angle APE is also equals to alpha. Already this alpha is there. I need a point E such that angle APE is equals to alpha. So now if I join this one, so this angle as we mentioned should be alpha. Definitely the lower angle should be 3 alpha minus alpha, which is nothing but a 2 alpha. Now if you see clearly this triangle APE, so at E, if you see the exterior angle, as these two interior angles are alpha and alpha, definitely this is going to be 2 alpha. So now if you consider points A, B, P, E, if you see the exterior angle is equals to opposite interior angle, definitely this quadrilateral is going to be cyclic quadrilateral. That is only I am mentioning here. So the points A, B, P, E are cyclic. Let me write as equation 1. And if you see clearly, as the exterior angle is 2 alpha, and here also angle EPD is also 2 alpha. Of course, this triangle is going to be an isosceles triangle, but keep in our mind, we'll talk about this triangle later. Now coming to the other part, like nothing but beta, 2 beta and 3 beta. If you see clearly, here also on BC, I am taking a point F such that angle BPF is equals to beta. So then what happens here? Angle BPF is beta. Here is also beta. Definitely this angle is going to be 2 beta, which is nothing but exterior angle of a triangle. And now if you consider points A, B, F, P are going to be cyclic quadrilateral. So clearly you can imagine a circle also. Now here first equation we wrote A, B, P, E are cyclic. In the second step we got A, B, F, P are cyclic. So by mixing those two, you can say that all the 5 points A, B, F, P, E are concyclic, or simply you can say all the 5 points lies on the same circle. Just you can imagine a circle like this. If you see all these line segment, what are that? AB and BF, FP, PE and EA are chords of this entire circle. Okay, that's fine. So now if you see these lower triangles, what are the triangles? PED and PFC. If you see these two triangles are going to be isosceles triangles for us. Clearly you can see 2 alpha, 2 alpha, 2 beta, 2 beta. Now if you join angular bisectors for these angles, definitely these two angles are going to be vertical angles of these two triangles. Now let me separate this one. As we mentioned earlier, angular bisectors of vertical angle of isosceles triangle will definitely perpendicular bisectors of the bases. So clearly you can see these two lines are going to be the perpendicular bisectors of these two bases. What are the two bases here? PF is there, here PE is there. But actually this PF and PE are the chords of this circle. So perpendicular bisectors of any chord definitely passes through the center, which means that these two lines are going to meet at some point. That point is going to be the center of this circle, whatever we can see here. So now as we got the center of circle, now AB is also going to be the chord here. So definitely perpendicular bisector of AB will passes through O only, which means angular bisectors of these two angles, perpendicular bisector of AB meet at same point. That is what we need to prove so simply with the use of all these four concepts. we can solve an International Mathematics Olympiad 2020 especially. Children, this is how an elegant question can be formed with the help of very simple concepts from our textbooks. That is what I want to mention from this problem. Hope you understood this problem very well. We'll meet in the next video with other topic. Until then, take care. Bye-bye. Your Haragopal. Thank you.